like, for example, greeting everyone on a seminar on composable, contravariant, combinatorial comonads, pausing, informing that the meta on refactors is the next door down, and seeing this pair. I hope that just by the mere action of telling this joke will set the tone for the next 45 minutes. As I said, I very much enjoy in-person meetups where people can interrupt me and we can go deeper into topics that we find interesting. Sadly, technology has not reached reality-level interaction yet, so I'll ask you to refrain from the questions to delve deeper into topics until the end of the talk, where we can have some Q&A. But don't hesitate to ask clarifying questions if there is something I did a bad job at explaining. Maybe we can have Ivan relay those questions, because I don't think that I can read and talk at the same time. So with that out of the way, let's jump in, shall we? From the top going down, we already, I'm going to thank Apiumhub for having this space so we can talk about this very interesting topic, that's refactoring. So thank you, Ivan, and thank you, Apiumhub. And let's start looking more in depth into the title, Refactorings. Refactor, a symposium on the desires of developers. I hope that as good sane developers, we all want to put these words in a balanced binary tree. So let's start in the root. And symposium means a drinking party. So I hope you brought your own drinks. Let's get a bit serious. So the keyword here is refactor, as you might have expected. So before we delve much deeper into what refactor is, let's try to define it now. So according to Wikipedia, refactoring is restructuring existing computer code, changing its factors without changing its external behavior. That's it. Thank you all for coming. Drinks are by the door. Sorry, that's one. Promise. So our definition, as with most great definitions, it tells us very, very little as what the refactoring is, and it requires us to go one step further into many of the words, like what is restructuring, what is external behavior, and the rabbit hole keeps spiraling down. So instead, let's try to define it in our own words. And I like to think about refactors for the next 45 minutes as an action to optimize code for the ability for it to be understood. That means maybe you might have had the chance to work with optimizing for memory allocation. Maybe you optimize code for speed or better error handling. Well, refactoring is just that, but for a human-to-human interaction. So for the next 45 minutes, let's try to put the focus on us humans, on how we understand code, our virtues of finding patterns, creating layers of abstraction, and multi-model representation of ideas, and shunned away from details and minutiae on how to actually make this happen. But let me be crystal clear, I find it very valuable for meetups and workshops and the like that are more hands-on and deep dive into the details. Heck, even I have such a workshop in Apiumhub Academy focusing on Java environment and its tools. But this is not that. Here we'll try to discuss refactor in a broader way. Hopefully it will provide less useful in a tactical sense, but more powerful in general. Words like powerful and useful here are devoid of emotion. They come from this idea of a spectrum of abstraction. There's a great talk by Cheng Lu, which I very highly recommend you go and watch. But the 5-word summary is that the broader something is, the less useful. With the first title out of the way, let's go to the second one. That is me. I'm currently working here in Apiumhub, and I had the opportunity not only to work with multiple code bases, but I've spent much time finding patterns from code reviews I've done and had been done to my precious code, distilling conversations that arose while pair programming or discussions among my peers. I am by no means a subject matter expert, but I think I have enough of experience to at least plant the seed on how we think we should treat this as the art of coding. So we talk most meetups and talks and books that I've read over the years about refactoring present you with some hideous code that I very much doubt somebody would have typed and committed to it. But nevertheless, the prototypical first example of a refactor I see thrown around are either a rename or an extract method. And usually the authors do some wizardly key presses on their IDEs and change one variable name to another. And we are fascinating that they change correctly every old value that was intended and not every string in a file, and continue explaining another refactor. But I'd like to pause for a second and debug this process of actually refactoring. So let's brush up on what renaming means. Renaming means, well, changing the name of one thing to another. It does nothing to change the structure of the code. It just adds or subtracts context from a cognitive scope rather than a lexical one. I would very much love to have some sort of interactions, though I don't think that it's feasible in the platform, but feel free to add me at Twitter or send me a message via email. And I would like to see examples of bad names that you saw, even ones you introduced yourselves. I, for myself, have left some foos on bars in the code that shipped because I couldn't come up with a better name. And a vexing name like foo is much better than something like super secure, fast looper 300. Maybe it is, maybe it's not. So let's look at the I or order row, because I find it very interesting. And this refactor, we introduced a new idea of an order row. Nowadays, I would advise, and I would take a strong, stern look at why is the idea of a row part of your domain? Like, how about an order? Does anyone understand the culture? Does anyone that understands the culture of the domain or the code base understand what an order row is? Maybe they do, maybe they don't. And even if the language is, in fact, ubiquitous and everybody understands it, subtle things can be looked over. Like, for example, in a zero-index language, the order row, an inherently humane and one-index mindset type of idea, is not the same as I. So we don't represent the same concept, but there is an isomorphism from one thing to another. But they're not quite the same. And let's remind ourselves, like, a refactor will not change the external behavior. It will not change what the code does. So we're not introducing any bugs. But for we are not introducing any bugs, but we're putting the pieces in place for other bugs in the future to arise if we choose a bad name. The other one that we've talked about was extracting methods. And this secretly does two things. One, it joins pieces of code together. And the second one is provides a digest, like an explanation on why one has joined the two things. So again, we are often quick to leverage our IDEs, select the 3 lines of code, press some complicated keybinds and a bit of magic and a lot of computer power, get through the code below. But it's interesting that we're joining the notion of printing to the idea of generating an amount. And this is a choice that we might have done inadvertently. Maybe we think that we should split these things apart, and calculating the amount is not part of printing up the details, so we can end up with a code roughly the same, that looks like this. Or maybe you want to go to another way and decouple the way of printing from the formatting on the output, but not the generation, like so. So tools are there to help us. Like our IDEs usually can help us do any one of these things. It's not a matter of the tools are not there. But hopefully, with this very simple and small synthetic examples, they help me illustrate that even the first thought refactorings have come with a lot of heavyweight consequences and decisions. Like, do we care about this part of the code or this or this? Like, what is the important part? And that is something that we have to choose. Like, we are trying to optimize for understandability. Like, so let's try to ponder why that is the case, and if other refactor patterns fall into the same problems. I found roughly 3 wishy-washy ways of categorizing refactors. Don't quote me on this. There is an extensive list on refactoring, their names, their uses in this refactoring.guru. Highly recommend going to that source. So the first thing that most refactors do is they change or they delegate to a better suited abstraction part of the concern that the currently held abstraction, like splitting the output from the formatting details. The next broad category is the ones that introduces a new abstraction, like they reify an idea, such as the ones that we saw earlier with the rename of the extract method. Here we come up with a name for something that otherwise had a different name or no name at all. And the third one is removing, and which is basically the inverse of the last two, where our previously held abstraction does not conform to our new understanding. So we remove the middleman, we remove impossible code paths, and we move away from one abstraction. As you can see, they all revolve around the idea of an abstraction. So let me hit you with another core concept, very much in need for evaluating refactors. An idea I rarely hear talked about when discussing the topic, but I feel core to evaluating when a refactor is either good or bad. Again, Wikipedia does very little to help us understand what an abstraction is, but the main gist of it is where we group similar things and hide details with the intention of reducing the amount of information needed to understand something. We lose precision, or implementation details, one might say, under one idea, so to reduce the cognitive load. And we are very limited on our ability to handle resources and handle a lot of abstractions at the same time. So reducing the amount of them helps us gaining more ground. We are already using a ton of abstractions. Like there is, when we read a code, we are not thinking about electron movements or voltages or bits. For most of the part, we don't even think about memory addresses. So let's try to nail down what makes a good refactoring, and as a corollary, what makes a good abstraction. The way that I do it, my smoke test, if you will, is I try to role play having to explain the changes to somebody else. And if I find myself telling, then you print the details, then you start, and they stop me immediately and ask me, hey, that printing of details part, what is it? What does it entail? It is very important. Then I've detracted from the original goal of improving interhuman communication. So the question after any refactoring should be, did we lessen or did we grow the cognitive load for some future reader? And by now, you might start thinking that I want you to go back to your projects and inline every method, every function, every variable, every object. You can avoid naming things altogether. This way, all the synthetic names we can come up to will be gone. No more factories, controllers, strings are gone. That is not what I'm advocating, but maybe, but no. We've talked much about the cost, but let's not forget that with them, there also comes work that they do for us. And there's a reason that they exist. There is no such thing as a zero-cost abstraction. I'm sorry. There will always be some cost. Even if we want to disregard build times or runtime times, there's always a human cost component. And the last one, the human cost one, is the one that I want to focus our attention to. There is a very interesting talk, albeit a lot more technical and a lot more C++ oriented, by Chandler Carruth. I, again, highly recommend the talk. It is a bit long, but I think it holds a lot of ground. And on a slight tangent of a tangent, I love when I can cross-reference things from other fields, like psychology, where, again, I am no expert. But I'll leave you with this very interesting read about the value of an abstraction and the way to explain how abstractions are useful, again, from a psychology and cognitive type of standpoint. It's rather short read, so I would hope that I can get you the links for them and you can check them out for yourself. So the last question would not be what's the cost of introducing or changing an abstraction, but rather is the work outweighing the cost. Oops. So, and keep in mind that there is an intrinsic cost that we paid in the past from our experiences, not only way back when we started learning programming, but even before. And again, something that I would very much appreciate you reaching out to me is, do you ever realize that we borrow a lot of terms from other disciplines and life itself for something that sometimes are not really related? Like, I love to read examples and words of abstraction that we borrow from other things, and bonus points if they have nothing to do with the original idea. Like, for example, there's a vocabulary that no matter what languaging, what program you're using, most of the times we start the program with a main, and we have I and j as looping variables. We call streams things that information flow, and that sort of comes from life. And this is something that I've heard once, and I repeat without much looking into it. But apparently, caché comes from the French word cacher, that means to store supplies closer than the main place you get supplies from, which kind of makes sense for a caché, but I don't really understand how we got from the French word to the actual term in computer science. So let's go back again to this I versus order row. Like, yes, the work that order row is providing is much higher, but their cost is also high. And the cost of I as an iterator must have been paid when we were reading a Stack Overflow question on for loops 10 years ago. Moreover, I think that in any one code base, consistency is king. So don't fall prey of analyzing our refactors in a vacuum, like we are doing. Maybe order row is exactly the best name for the looping variable. Maybe it's not now, but the steep cost will come in the long term, provide much more valuable work, and thus we need to decide what strategy of depth we'll like to utilize. But this is very much not a thing that you can think in the vacuum. You need to look at what the refactor means in the scope of the thing that you're changing. And all of these hard decisions are just looking at the most simple of refactors. Like imagine all the layers of abstraction vocabulary that we introduce when we do more disruptive structural changes, or we add new features, or we remove features whenever we do that. And on sort of that note, I'm recently been seeing more and more tools that provide code synthesis to provide like a common language to talk about code structure and the reasons and ways to reason about code structure and code as a general term. I hope that in the future and the medium term, we can be at a place that we pay the cost of understanding that languages and the tools and that vocabulary early, and that we can reason about code in a more high level. I could talk on and on and on about program synthesis, and I would really want to, but for the sake of time, I'm going to skip it. But I'm going to recommend this talk about Wingman by Cindy McGuire on the Hasley Weekly podcast. Again, I'm going to set the links out via the meetup. So I'm sorry that this meetup will not end with a quick, fast hacks to make your code 5 times more readable, or learn about this refactoring that IDE developers don't want you to know. But that's basically the point I want to make. It's hard to communicate, and refactor means improving interhuman communication. And that is a very hard ordeal. So even if we have automated tools to rename or extract methods or inline variables, there is no automatic way for machines to tell us when the code is more human readable. There is no correct way to refactor something. And the tools are deceitfully simple to do, but naive utilization yields no more readable code. Even the fact is that many times the naive utilization yields less readable code. So my advice to you is that you take the time to explore the problem space. Things like duplicated code don't immediately mean that the code should be pulled into a common ancestor. If the ancestor will have a synthetic name, build a way to have a quick feedback loop on the external behavior, the thing that doesn't change, and write code that adheres to those rules and iterate. Find the correct abstraction you need, not something weird like the super fast, super secure string loop with 300. Unless your domain calls for it, which I would be very interesting to know what your domain is, so call me. So for those astute among us that are looking at the time and thinking we still have 20 minutes left, let me tell you what tools I've gathered along the way to improve my ability to measure the quality of an abstraction, and by direct relationship, those of the refactors that I do. Looking at my own code is very hard to find places to improve in a communicational sense. I know completely all the context that I had when I wrote the code, most of the times. So I find that whenever I try to explain in words, at a very high level, what changes entail, it is useful for both a future reader and to me to see the pain points on the explanation. Having done many code reviews, and moreover, when I talk about code, and as you can see, I really like talking about code, I came up with a template of sorts. I find particularly useful leveraging commit messages to do so. So often I write messages for over 20 lines explaining the scope and the background and the needs for the change and any caveats that are in the code or any alternative solutions that were explored but ultimately discarded. This helps me narrow down what are good abstractions, words and vocabulary that I can freely say and explain without having to dive much deeper. Pair programming is also a great tool that helps forcing the communication at a very early stage. That way we any amount of people can have the context and can challenge each other on what are and what are not good abstractions. But another tool that I wanna emphasize is I really enjoy reading other people's code. I particularly find interesting parsers and languages. So whenever I see one in GitHub, I try to skim over the parser or the language or the VM and see what things I can understand, at least at a very abstract level. If I can understand something, which is not often the case, I try to figure out what the techniques the author used, maybe inadvertently, that I could figure out what they meant or what the abstractions they were using. And all of these are things that happen after the fact. And they're right, as refactoring sort of implies, to having some code and optimizing for the readability. But I also want to mention that there's something somewhat new of a technique that I've developed, is beginning that I like to call the desire-driven development, where I, without any code, try to explain what should happen in prose, and then try to formalize that explanation into code the most direct way possible, and then build any abstraction that I inadvertently created whilst explaining. So if we were to plot this meetup happiness over time, we started, hopefully, very high with a somewhat interesting introduction and some silly jokes. Then we quickly went downhill as I talked about how intrinsically hard the problem is and how very little machines can do to alleviate this. But then we started to see the light at the end of the tunnel, where I went over tips and tools. But that, I'm afraid, was the local maximum. Things will go downhill from here. So let's start documentation. For the longest time, I thought to myself that the lack of documentation of these high-level concepts was incompetence. But I recently realized that for each feature, each bug, each improvement, they need a different abstraction. And abstraction, by the definition of the word, means hiding details. These details might be important or irrelevant, depending on the angle that you're trying to understand. Code needs to be complete to deal with every edge case, every possibility, even if it has a very niche case that is very much irrelevant for the broader understanding of things or for the understanding of things that we care about at that particular moment. But we, humans, if you can call ourselves humans, we can deal with incomplete and even faulty descriptions. So let's leverage our intrinsic ability to understand either code or prose. Documentation is a tool, not a requirement, most of the times. And in my experience, it can help greatly the initial ramp-up of understanding an abstraction. Worry not, I'm not advocating of documenting every method, no matter how big or small, how core or neighboring. I'm talking about external behavior, the thing that, again, seldomly changes. Think more about README and less about Java docs. And we're very, very quick to refactor into a new shiny abstractions. I've done this many, many times. But we often forget the cognitive load that others will incur. After all, if we could come up with an abstraction, that was the hard part, right? Others will simply read it and don't have to go through the painstaking process of conjuring the abstraction app. Probably you have read way more code than written, and you can attest that this simply is not true. So again, let me reiterate, I'm not advocating to inlining every method, though I like to end this meetup then with one major bullet point. And this is that refactoring is hard. Like, it's impossible for automated tools to say whether a refactoring is good or bad. Only humans can. So go out there, explain code to other humans, find what works in terms of explanation, find what does not. Leverage the work of the abstractions that are already ingrained in your culture, in your code base, in your team, and don't think about refactors in a vacuum. And look at ways to improve communication. Code is one of the best ways because it changes when the code changes. But there are many other tools around there that can help improve our ability to communicate. Tests, a common culture, or even the dreaded documentation. We've been talking about refactoring to improve the idea of a human-to-human interface and with code as a medium, and I assumed that the changes did not, in fact, alter the external behavior, aka the behavior, some might call. And we talked about a feedback loop to ascertain that is the case. I hope that by now I don't need to convince you that tests are a key part of making such postulates, and automation of said tests greatly improves the feedback loop. But there are many additional ways in we can do this, such as formally proving code or formally proving code. I was way faster than I thought I would be. So with all that said, I want to thank you again very much for spending your time and hear me rambling about refactorings. And a special thanks to all these lovely people in particular that creating the work and shared it online. And to Ivan and Apiumhub for letting me borrow the time to do this. So that's about it.
Thank you very much, Joaquin. I think it was a really nice explanation, really fast as well. I was wondering if anyone has any question they might ask.
Well, I have a question. How will you know when it's the right level of optimization on a refactor?
Great question. So luckily, most of these type of question I can answer with it is very hard, and it depends. Like that's the universal answer for any of these questions. But let me give it a try. So, what is the correct level of optimization on communication? I think that you need at least enough of it for your teammates or anyone that is going to read the code to be able to understand. You don't need to optimize for somebody who doesn't understand the domain, right? Because we can fall into that trap of trying to make it incredibly obvious to somebody who doesn't know about the domain of the code. But that makes we have to come up with such a convoluted way of explaining things that we have to cover everything. And again, we have a limited amount of capabilities to understand abstractions. So you need as much as it is needed for other people to understand, like other team members or other people that understand the domain to be able to understand, no less, and not much more either. So it's hard to find the right balance. Great question, though.
Thank you.
Is there any more questions? If not, I think we can close this meetup here. Many thanks, Joaquin, for the symposium. It was very interesting. And it's a wrap. Thank you, everybody, for passing by. And good weekend to everybody. Thank you.
Thank you, Van.